So we'll be starting chapter 4, that's simple interest and compound interest. What usually happens in this chapter is that around we can expect around two questions or less than two questions, even one question for sure. One question for sure in any of the competitive exams is definitely going to come from simple interest and compound interest. Simple interest being a simpler topic is easy to understand. Compound interest being a little complex takes a little more time to understand, but both of them are majorly formula based and a little bit concept based. So why and how did simple interest and compound interest originate as a topic? So money is not readily available with everybody all the time, be it businesses, be it private individuals, be it even government. Okay, so whenever we need to loan, loan means you have to borrow money from somebody. So whenever you have to get some money on loan, at that time two kind of interests come into play. Because let's assume I borrowed 100 rupees from a party, and after 2 years I return the same money to the party 100. The party will tell me that, do you think I'm a fool? Why did I even give you money if I was supposed to get the same amount back? Why is the party, or why is the lender demanding more money than 100 rupees? The reason is that the 100 rupees which he gave to you, or the 100 rupees money which he gave to me, could not be utilized for his own needs, or could not, or wasn't available with him. He gave it to me. That is why there is a concept of interest, that there is a concept of interest which comes into play. And I will have to pay more than 100 rupees. Let's say I will have to give 10 rupees extra, and I would eventually have to give him 110 rupees. So this interest which comes into play is about simple interest and compound interest. There are two kinds of interests, one being the simple interest and the other one being the compound interest. I'm assuming the same issue which I was talking about. 100 rupees I borrowed from, let's say, ICICI Bank. Okay. And ICICI Bank told me that I would give you the same amount of money, like 100 rupees, on simple interest. And the interest rate which they gave me was 10%. Let's assume I kept this money with me for 3 years. Okay. I kept this money with me for 3 years. So ICICI Bank gave me 10% rate of interest for a period of 3 years. So what happened at the end of the first year? I had 100 rupees with me, and a 10% interest was added. The 10% interest would be applied on 100 rupees. So 10% of 100 is 10 rupees. So 10 is the first year interest. Plus talking about the second year interest, it's again going to be 10. And talking about the third year interest, it is also going to be 10. Okay. So 10 is also the third year interest. At the end of 3 years, when I am returning the money, I am not supposed to return 100 rupees. I am supposed to return 130 rupees. Okay, I am supposed to return 130 rupees. But when ICICI Bank told me that I would apply a 10% compound interest, that time I felt that compound interest is something different. It is a little more complex. So maybe there is a good possibility that this would be more beneficial to me. But the reality was pretty different. The reality was that in the first year, I borrowed 100 rupees. In the same first year, I had to pay 10% interest. This 10% interest came out to be 10 rupees, and I was very happy that at the end of first year, I am only having a loan of 110 rupees with me. At the end of the second year, the picture changed because again a 10% was applied, not to 100 rupees but to 110 rupees. So at that point, at 110 rupees, when a 10% interest rate was applied, the amount came out to be 111 rupees. So at the end of the second year, I was supposed to pay back 121 rupees loan. Okay, I was supposed to pay back 121 rupees loan. But I'm supposed to keep it for 3 years, as the tenure of the loan is 3 years. I was really expecting that the compound interest should have been applied to 100 rupees, but that is not the case. The total amount, or the total loan amount, now stands at 121 rupees. This 121 rupees would again be applied against a 10% interest for this year, and the interest would come out to be 12.5%. 1 rupees for the third year. So 121 plus 12.1, this gives me um 133.1 rupees. So these are two options that I have. The first being a simple interest, which is 130 rupees, and the second one being a compound interest, which sounds a little better as compared to simple interest, but it has a repercussion of plus 3.1 rupees. Okay, so compound interest is the same for two amounts. The compound interest and the simple interest is same for two amounts for the first year only, and moving forward it tends to increase, it tends to go higher. So that is the difference between simple interest and compound interest. Moving on, we will be learning the formulas for simple interest and compound interest for quite some time. Maybe around 20 slides we'll be practicing questions on simple interest. Then moving on, after that we will be learning concepts of compound interest and installments. Okay, so what is actually simple interest, I'll tell you in the next slide. So there are a few basic formulas that are used, and there are a few basic terminologies that are used. The first one being P. P is nothing but the principal. What happens in principal? Principal is the amount which I am borrowing. Amount being borrowed. That is the principal. Then talking about time, that is T. T is the time against which the amount is being borrowed or the loan is supposed to be repaid. Then talking about R, R is the rate of interest. Rate of rate of interest. Rate of interest is usually denoted in per annum basis. When I say per annum basis, I also mean to say that this is a per year basis or for 12 months. Okay, for 12 months. We have P, we have R, we have T. Then we have the concept of SI. The SI is also called simple interest. Simple interest. Then we have the concept of amount. Then we have the concept of amount. Amount is nothing but principal plus simple plus simple interest. Okay, amount is nothing but principal plus simple interest. So you will have to understand the formulas now. The first formula is the formula of simple interest. The formula of simple interest says that the principal multiplied by the rate of time multiplied by the rate multiplied by time whole upon 100 would become my simple interest. Okay, P being the principal, R being the rate of interest, and T being the time whole divided by 100. Why do we need the concept of 100 here? Because R is represented in percentage form. That is why there is a 100 which follows in the denominator, right? I'll be moving to the questions now. The questions are not very difficult, but I would want you to look very, very carefully. Okay. So the first question is here. I'll change the ink of the pen. Um, Find the interest on rupees 1000 at 5% for 10 years. Okay, this is the time with me, this is the rate of interest with me, this is the principal with me. I am being asked the interest. There are going to be situations when you'll find the word interest available all the time, and when it is only interest, when it is only interest written, then you have to by default assume that it is simple interest. Okay, and when the principal and the interests are getting added year on year, that is when it becomes compound interest. It will specify in the question if it is a compound interest question. It might not specify in the question when it is a simple interest question. I'll use the same formula which I talked about. The simple interest is equal to P into R into T whole upon 100. The value of P is 1000, the value of R is 5%, and the value of T is 10 years. Whole upon 100. 2 gets cancelled with 2. This gives me an answer of 500 rupees. Okay, this gives me an answer of 500 rupees. For 10%, I will have to pay 500 rupees against a sum that I borrowed for 1000 rupees. Okay, for the sum that I borrowed for 1000 rupees. Okay, I'll move on to the next point. This is the same thing which I've talked about. The only difference is that amount that we're talking about here. Amount is the final thing which I ultimately have to return. That will definitely consist the principal plus the simple interest. Okay, principal plus the simple interest. Okay, find the interest on 5000 rupees at 10% for 9 months. Now this question is a little typical, the reason being that the time has been given as 9 months. Okay, 9 MOS means months. So when I talk about 9 months and I talk about the percentage of interest, I told you that R is usually given on percentage per annum. Okay, when I say percentage per annum, that time I assume that 10% is supposed to be given out for 1 year's time at least, or 12 months time at least. But as I have the time being 9 months over here, that means this 10% wouldn't be applied completely. This 10% wouldn't be applied completely. This 10% would be applied in the form of 9 by 12, or 9 months upon 12 months. So I'll quickly use the same formula which I talked about. Simple interest is equal to P into R into T upon 100, and T would be in terms of 9 by 12. The principal being 5000, the interest being 10%, and the time being 9 months by 12 months. The reason I'm introducing a 12-month over here is that the rate is in 10% per annum basis. Okay, the rate is in 10% per annum basis. 3 3 is a 9, 3 4 is a 12, and 4, this 0 and 0 is gone. This leaves me with a 25. 5 into 25 is 125. 125 into 3 is 375. So 375 rupees is my answer. I hope everybody is very comfortable with it. I'll be moving on. How long will it take for a sum of rupees 450 to accumulate 81 rupees in interest at a simple interest rate of 4.5% per annum? We'll be using the same formula of SI being equal to PRT upon 100. When I'm writing the formula in a rudimentary form, I tend to write P multiplied by R multiplied by T. When I write it at an advanced level, I did not even put any symbols between them, because it is by default assumed that P is being multiplied by R and it is also being multiplied by T. Okay, I hope you get that very well. How long will it take for a sum of rupees 450 to accumulate 81 rupees in interest at a simple interest rate of 4.5% per annum? Okay, so my interest, or my simple interest, which I usually calculate, has already been given as 81 rupees. The principal has been given as 450 rupees. The rate of interest has been given as 4.5%, and the time needs to be calculated. Okay, I'll put things into perspective by using the formula. 81 is equal to 450 multiplied by 4.5 multiplied by time whole upon 100, and this point would again introduce a 0 here. Okay, so I have 9 into 9 is 81, and this is 950 is a 450 and 9 fives are 45. So 81 becomes 1. I have 5 fives. I'll first cancel 1 0. I have 5 fives are 25 and this leaves me with 4. So the value of 25 fours is 100. So the value of time would come out to be 4 years. Okay. Okay. I hope you're able to understand completely where I'm coming from and where I'm going. So that's my motive. Now, there can be times when simple interest is expressed in the number of times of the principal. Okay. Simple interest can be expressed in number of times of the principal. So we were talking about when simple interest becomes x times of the principal. Usually, whenever we talk about simple interest in mathematical terms, we get a number here. And the simple interest is equal to PRT whole upon 100. But sometimes there is a possibility that this number doesn't show up and simple interest is given in form or in times of the principal. Let's say 2 times the principal is the simple interest and then we again get a PRT upon 100. In this manner, the principal gets cancelled off. The coefficient of the principal, which is maybe a higher or a lower number, stays there and it eases down the calculation. Okay, it does nothing but eases down the calculation. Got it? So I'll quickly give you the first question. In 5 years' time, the simple interest on an amount of rupees X is 2/5 of the principal. Find the rate of interest per annum. I'll use the same thing. 2 by 5 times of the principal is equal to 5 years, the principal multiplied by the rate of interest whole upon 100. The principal gets cancelled with the principal. The 5 and 5 make 25. This 25 fours 100 and the rate comes out to be 8%. For the ones who found this to be a little difficult, I'll slow myself down. I will slow myself down and try to explain the entire story in a very easy and shorter, rather longer, easy and very elaborated manner. The time that we can see over here is equal to 5 years. The simple interest on an amount of X, that means that the amount or the principal that we are talking about here is nothing but X rupees. Talking about the rate of interest, we need to find that out, and PRT. And talking about the simple interest that we have here, it is nothing but 2 by 5 times of the principal, which is X. Okay, so when I have X rupees as the principal, now I will apply the formula of SI is equal to PRT over 100. When I have 2 by 5 times X being the simple interest, and then I multiply it by 5 years multiplied by X multiplied by R, which is the rate of interest upon 100. At that time, I'm not cancelling these things out. I'm taking 5 down here to 25. Then this would get cancelled as 4. Then X would get cancelled with X, and the rate of interest that I would achieve from it is going to be nothing but 8%. Okay, the rate of interest that I'm going to achieve is going to be nothing but 8%. I hope that's comfortable for everybody. I'll move on. The simple interest on a certain sum is 1/4 of the sum. Okay, the simple interest is 1/4 of the sum, and the rate of interest per annum is 4 times the number of years. If the rate of interest increases by 2%, then by how much will the simple interest on, then how much, there's no by, then how much will be the simple interest on 3600 rupees for 6 years with an increased rate of interest of 2% plus the old rate of interest. Okay, so these are nothing but two questions in one single question. I would follow up with the first question first. Okay, simple interest on a certain sum, the SI is equal to 1/4 of the principal. This thing being established, the value of principal is principal that I'm using here. The rate of interest is equal to 4 times the number of years, and the time is equal to time. Okay, I have all my variables in place. I'll quickly put it down in a formula of simple interest is equal to PRT over 100. 1/4 of the principal is equal to principal multiplied by 4 times the time, multiplied by time whole upon 100. Okay, the principal gets cancelled with the principal. We have time square over here, and we have 16. So what we get here is 100 over 16 is equal to time square. The value of time from this equation comes out to be 10 by 4, or 2.5 years. I have the time with me. Now there is a new time component which is 6 years, which is coming in the second question. But the thing which is rolling on, or the thing which is being carried forward from the past question to this current question, is the rate of interest. So I will quickly calculate the rate of interest. The rate of interest is 4 times the time. The time being 2.5 years, when I multiply it with 4, it gives me a 10% rate of interest. As I have the 10% rate of interest, I can move to the second part of my question. It says if the rate of interest increases by 2%, or rate dash is equal to 2% plus 10%, it would reach 12%. Okay. Then by how much will the simple interest? Then why do I say by? Then how much will be the simple interest on 3600 for 6 years? I have the principal as 3600 rupees. The time which I have is 6 years. I won't rewrite the formula, but I'll be using the same simple interest formula. The formula says P, which is 3600, the rate of interest being 12%, and the time being 6 years. Okay, I would divide it by 100. This would be my answer. Okay, so what do I have here? I have 36 multiplied by 12 multiplied by 6. I can take a component of 12 multiplied by 12 multiplied by 6 multiplied by 3. This is 12 into 12 is 144. 144 into 18. 144 into 18. This is going to be my answer. So anything with a 2 in the back is going to help me. And also anything which is divisible by 3, by 9 as well. The only number which is divisible by 9 is this one, and there is a 2 at the end as well. So this is definitely my answer. This doesn't mean that I don't know the table of 18. I do know that 18 fours are 72. The 7 goes in carry. 18 fours are 72. This becomes 9. This becomes 7. 18 ones are 18. 2, 5, 9, 2 is my final answer. Okay. I'm just showing you a few better tricks. I'm just showing you a few better ways to solve the question by using unit digits as well as sum of digits. Okay, unit digits as well as sum of digits. Good enough. Let me move on. Okay, different principal and rate involved. This is just a concept name. When we start doing the questions, you will get to understand that this is very easy. Okay. Okay. Two equal sums were lent on simple interest at 6% per annum and 10% per annum, respectively. Okay. So this is sum, this is sum, or maybe let's call it principal. Okay. Let's call it principal. The principal, I'll remove the word sum from it. Two principals were equal in number. Two principals were equal in number, and they were given at 6% and 10% respectively. The first sum was recovered 2 years later than the second sum. This means this was t plus 2 and this was 2. This shows a gap of 2 years. 2 years more were invested on the first sum. And the amount in each case was 1105. The amount in each case was 1105. Okay, these both are equal, and these two are the amounts. So they are asking me what is the value of P in this issue. When the amounts are equal in nature, then I can say that the amount 1 is equal to amount 2. When I say amount 1 is amount 2, and I also know that the principal is the same in both cases. Principal is equal to P R1 T1 is equal to principal into R2 T2. This is going to go under 100 and this is going to go under 100. This is me talking about amount. Amount is equal to principal plus SI. Similarly, amount 2 is also going to be principal plus SI. The only difference is that the simple interest on both the sides are different. The principal gets cancelled out because the other side would go to the other end and become minus. It will cut out to 0. The principal would get cut off from here as well. The 100 would also get cut off. The output which I get from here is R1 T1 is equal to R2 T2. The value of R1 is 6%. The value of R2 is 10%. The value of T1 is T plus 2. The value of T2 is T. Okay. So now things get cancelled. Percentage gone. 2 3s are 6. 2 5s are 10. This is equal to 5 times T and 3T plus 6. This goes here. 2 times of T is equal to 6. The value of T comes out to be 3. Okay. I have the value of T which is coming out to be 3 years. Now I'll quickly apply it here in the formula of amount. Okay, I'll quickly apply here in the formula of amount. Amount is equal to principal plus simple interest. The amount is 1105 plus I have the principal with me. The principal is something which I need to find out, plus the simple interest also has a component of principal, multiplied with 5 years which is the time, multiplied with 5 years which is the time because t plus 2 is 3, and 6% which is the rate of interest, divided by 100, divided by 100. This becomes, I'll take p common, this becomes 130 over 100 and 1105. This gives me 13 sevens are 91, no, 13 eights are 104. This gives me 8500 rupees as my principal, and this is where my final answer lies. Okay, we had to reach a point where we could find out the time. Once we have the time, we went back to the same equation where we started from. This is the main equation. This main equation was used again. Okay, this main equation was used again. I hope we are doing good. The answer is yes. Let's move on. If a sum is invested at a simple interest, then it becomes 3 by 2 times of itself in 4 years. When I say something has been invested in simple interest, then the amount is composed of principal plus simple interest. It is saying the simple interest or the amount which is invested, let's say that is P, which is invested, it becomes 3 by 2 times of P. Okay, P dash becomes 3 by 2 times of P. What does it indicate? This basically indicate that this P dash is nothing but the amount. The amount says that I am P plus SI. When P plus SI becomes 3 by 2 of P, at that time the value of SI would come down to 3 by 2 of P minus P. This gives me a 0.5, or this gives me the value half of P as the simple interest. Okay, this thing has been established that the simple interest is half of P. I already have the time with me, which is 4 years. So the simple interest is equal to half of P. It is equal to PRT by 100, the P being the same, R needs to be found out, and T being 4 whole divided by 100, right? This would give me 50. The principal gets cancelled with the principal. The value of R comes out to be 50 by 4, or equal to 12.5%. okay, or equal to 12.5%. I hope this is clear. I hope this is understandable. I hope this is good, right? Let's move on. When two different simple interests are calculated and their difference is given, okay? The simple interest on a certain sum for 3 years. Why did I not stop over here and tell you more about it? Because the entire chapter or the entire concept is based on the simple formula of SI being multiplied by, or the SI being equal to principal into rate into time upon 100. All the concepts which are going to come in simple interest are going to be simple or mere modifications of whatever we are talking about, okay? So there is no need to stop at each concept. It is best to directly approach the questions. The simple interest on a certain sum for 3 years at 14% per annum is 4200 rupees less than the simple interest on the same sum for 5 years at the same rate. This means that the simple interest for a period of 5 years, when it is reduced by 4200 rupees, this gives me a simple interest for 3 years, right? This is the main equation that I'm talking about. This is SI, this is also SI, this is the main equation. The SI for 5 years and SI for 3 years. I need to find out the SI for 5 years and SI for 3 years. In that, I would have a component, of sum, which means I would have a component of principal, which needs to be calculated. For 5 years at 14% per annum, 14% per annum for 5 years upon 100 multiplied by the principal. This is the simple interest for 5 years. Minus 4200 would give me principal multiplied by 14% per annum multiplied by 3 whole upon 100 whole upon 100. This would create my final answer. Okay, I'll let the things take shape. Okay, 5 minus 3, everything is the same in the equation, only 5 minus 3 needs to be done, which is equal to 2, and 4200. This is 14 3s are 42, this is 300, this is going to be 150, and this would give me a principal of 15,000 rupees. Okay, I would give you maybe a moment for this question to sink in, and then I will move on to the next part. I believe the question would have sunk in your minds, and this was nothing but a simple equation which we talked about. If you can figure out the main equation, then you can easily solve the entire question using the simple formula of SI being equal to PRT upon 100. Yep, good enough. Let's move on. An amount of P was put at simple interest at a certain rate for 4 years. If it had been put at 6% higher for the same period, it would have fetched 600 more interest. What is the value of 2.5 times of P? I will be following the same approach. Simple interest being equal to PRT upon 100. An amount of P rupees what was put up at simple interest for a certain rate for 4 years. Okay. This is P multiplied by 4 years multiplied by rate upon 100. This is equal to my simple interest. Had it been put at 6% higher rate, means the rate would have gone higher for the same period. It means it is multiplied by 4 again. The principal also would have been the same upon 100. This thing would have had a higher rate of interest, which is 600 rupees higher. Okay, which is 600 rupees higher. It would have fetched 600 more interest. Okay, so I know the relationship between the two, that when P into 4 into R plus 6 whole upon 100. This is simple interest. This is equal to P into 4 into R whole upon 100 plus 600. When this goes here, the concept of R goes into vain. P into 4 into 6 whole upon 100 is equal to 600. The 6 gets cancelled by 6. This makes it 100. The 100 goes here. The 100 goes here. There is something missing, I believe. No, I think everything is fine. Yeah, this is 4 and 25. This is 4 and 25. It becomes 25. This means the principal has reached 2500 rupees. Now, as we have the principal, the question being asked is what is 2.5 times of P? When 2.5 is multiplied by P on both sides, it would give me 6250 as my final answer. Okay, 6250 is my final answer, which is 2.5 times of P. I hope you're able to understand. Good enough. Let me write it just a little more clearly so that the ones who see the PDF are not confused as to what did I do. And 6250 rupees. Okay, this is the answer that I'm looking for. I'll move on. When rate of interest is changed. Okay. A sum of rupees 4000 amounts to 5000 rupees, 5008 rupees in 3 years at simple interest at the rate of X% per annum. If the interest rate becomes X plus 2.6, then the revised maturity amount would be this 5008 is the first maturity amount. Okay, it is the first maturity amount. When I'm talking about 5008, this is the amount. When I'm talking about the principal, this is 4000. This gives me 1008. When I subtract them, this gives me a simple interest is equal to 1008. Now, the rate of the time has been given as 3 years and the rate has been given as X%. Let us find out the value of X% as soon as possible. 1008 using the same formula PRT. 1008 is equal to 4000 multiplied by 3 multiplied by X whole upon 100. The two zeros go away and 3 fours becomes 12. This leaves a 10 over here. This is 12 eights are 96 and 12 fours are 48. Yeah. So what am I left with here? I am left with 8.4% as my rate of interest or the value of X. Okay. This is also called X. If the rate of interest becomes X plus 2.6, that means a component of 2.6 is added to this equation. I get a rate of interest of 11.0%. So now 11.0 is the new rate of 11.0 is the new rate of interest. 3 years is the time and 4000 is the investment. I would apply it in the same formula. 4000 multiplied by 3 multiplied by 11 whole upon 100. This would give me 4 3s are 12, 132, 1320 would be my simple interest. As I have my simple interest, I need to add it with the principal so as to create amount. The value of principal is 4000 and the final output comes out to be 5320, which is the amount that I was looking for. Okay, good enough. Let me move on. A money lender claims that he lends money at a simple rate of interest of 8% per annum, but he cleverly includes the interest amount in the principal when he calculates it every 6 months. The effective rate of interest becomes what? Let's assume 100 rupees were taken from the money lender and 8% per annum was the interest rate. If at the end of 1 year, if at the end of 1 year, the money was asked to be returned. So 8% interest per annum would have been supplied. That would have given me 108 as the amount amount of settlement. Okay, 108 is the amount of settlement. But according to the question, he cleverly includes the interest amount and principal when he calculates it every 6 months. That means this 8% has been split up in two portions of 6 months each. This is 4% here, and this is 4% there. 4% here on the left, 4% there on the right. So against the 100 rupee which we have in the first place, 4% of 100, this gives me 104. Now this 104 is the amount to be returned had the loan period been only 6 months. But the loan period is 1 year, and the clever lender is also including the interest amount in the principal. Okay, so 104 is my new principal, is my new principal. This new principal would be subject to 4% interest. When I apply 104 multiplied by 4% upon 100, I get the answer as 4.16 rupees. When this interest amount of 4.16 rupees is added to not 104, not 108, but when it is added to 104, when it is added to 104.00, it gives me 108.16 rupees as the final amount which I am supposed to return. So instead of the 8% which was clearly visible as 108, my new amount is 108.16, or simply 8.16% on 100. All the percentages are expressed in terms of 100, so I can easily say that 8.16 is my effective rate of interest. Right, let's move on. Now there can be possibilities when the principal amount is split into two or more parts. Okay, a sum of 2700 rupees is divided into two parts such that simple interest at the rate of 15% on A and B after 2 years and 4 years respectively is equal. Okay, so it is saying that 2700,000 has been split in two parts, A and B. A is subject to a 2 year time and B is subject to a 4 year time. The simple interest on A in the end is equal to the simple interest on B, and the percentage is 15% here, also 15% in both the cases. Okay, okay. So the total interest received from both A and B is what? This is my simple question. What do I do about it now? What do I do about it now? I quickly calculate the simple interest of A, which is 15% multiplied by 2 multiplied the amount invested by A upon 100. This gives me 30A upon 100. You can see that I'm not doing any minute calculations anymore because they would eventually get cut off. Similarly, the simple interest on B is 15% of 4 multiplied by B upon 100, which is nothing but 60B upon 100. According to the question, the simple interest of A and simple interest of B are equal. So I would equate these two equations. 30A upon 100 is equal to 60B upon 100. The 100 and the 100 get cancelled off. This is 31 za, this is 32 za. So the ratio between A and B's investment comes out to be 2 is to 1. Okay. So that means A is to B has been split, or 27,000 rupees has been split in three portions, two of which goes to B and one of them goes to, sorry, two of them go to A and one of them goes to B. That means when 2 plus 1 is 3, so every 3 is equal to 9,000. So the 2 would be equal to 18,000 and B would be equal to 9,000. So now we have the principles in place. Now we have the principles in place. So for A, when 18,000 is invested, there is a concept of 2 multiplied by 15%, which would give me the rate of interest. This means 30% of 18,000, which is equal to 5,400 rupees. See how quickly I am doing it now. Now talking about B has an investment of 9,000. There is a component of 4 multiplied by 15%, which would create its simple interest, which is equal to 60% of 9,000, which is also equal to 5,400 rupees. This is also equal to 5,400 rupees. When this gives me, or how should I say, this proves the point that in the question, when simple interest of A was equal to simple interest of B, it eventually came out to be true that both the simple interests are equal. When I add both of them up, I get the value 10,800 rupees as my interest received together from A and B. Okay, I hope I was able to make myself very clear. Right, I'll be moving on. Similarly, just a second, where are we? I just wanted to understand of at what point where we are. Just a second. Okay. Hmm. Okay, so 6,000 is divided into two parts. Similar question. Okay, simple interest, first one 10%, and the second one is 15%. So again, there is a split up between A and B. A is on 10%, B is on 15%. Okay, and there is only 1 year involved. So 10% of A multiplied by 1 year's time upon 100 is equal to 50% of 15% of B multiplied by 1 year, which is the time upon 100. This gives me A upon B as 15 upon 10, or 3 by 2. And A and B together amounted to 6,000 rupees. Okay, together amounted to 6,000 rupees. If the value of A plus B is equal to 5, when 5 is equal to 6,000, that means every one is equal to 1,200. That means 3 is equal to 3,600. Similarly, 12 into 2 is 2,400. Through this, I am able, how much is the interest on each part for 1 year. Okay, so it's basically asking me to find out the simple interest. I would use A in this position. For A, the sum or the principal is 3,600. For the first part, the first part, the interest percentage is equal to 10% for A, and the time is 1 year. Okay, it's saying 1 year. The time is equal to 1 year. T into R into T, which is 3,600 into 10 whole upon 100. The two zeros get cancelled, and my final answer comes out to be 360 rupees, which is the simple interest on each part. Okay, simple interest on each part. Good enough? Okay, I'll move to the next question. So we are done with this particular question. We'll be moving on to our next target. Okay, so in this particular area, we talk about how the principal or how the interest becomes some times of the principal, and at that time we are supposed to calculate the rate of interest. We are not going to do anything special. We are going to simply apply the simple interest is equal to PRT over 100. Okay, need not move the formula left and right. It can be done without moving the formula as well. Okay, so a sum triple itself in 9 years at simple interest. Find the rate of interest per annum. A sum triples itself in 9 years at simple interest. Okay, the sum is tripling itself, or the principal is becoming 3 times of the principal. That means this 3 times of the principal has two components. It has the real principal inside it, and it has the simple interest inside it. So when we calculate that, we write that the principal plus simple interest is equal to 3 times of principal. That gives me the simple interest being equal to 2 times of the principal. Okay, always remember this. That means the 2 times of the principal, which is the simple interest is equal to principal into rate of interest into time over 100. The principal gets cancelled with the principal. The rate comes out to be 200 over 9, which is also equal to 22. This is 22 2 by 9%. Okay, the final answer comes out to be 22 2 by 9%, which is my rate of interest in this particular question. Okay, so always remember, need not go for multiple formulas in your brain. Use the standard formula and apply a little bit of logic. Use the standard formula and apply a little bit of logic. Okay, I'll be moving to the next question. In how many least number of complete years will a sum of money become more than 4 times of itself at the rate of 14% per annum on simple interest? Okay, first of all, it is supposed to become 4 times of the principal. I'll start off with this. Principal plus simple interest is supposed to be 4 times of the principal. That means the simple interest must be, and it is supposed to be more than 4 times. Okay, so the simple interest must be 3 times of the principal or more than that. Okay, at least 3 times of the principal or more than that. So I'll quickly use the formula that the simple interest is equal to P into R into T whole upon 100, where simple interest is nothing but 3P and the principal is here. The rate percentage of 14% has been given. Time has to be calculated upon 100. The P would get cancelled with P, and this would become 300 upon 14, which is the time period. Once I start cancelling things out, 14 twos are 28, another 20, 14 ones are 14. Yeah, 14 twos are 28, another 20, 14 ones are 14. I am with 6 over here. 6 is in 60, 14 fours are 56. Yeah, 14 fours are 56. So 21.4 years is my answer. Here it is talking about complete years, and here I'm getting 21.4 years. This answer is coming out only for 3 times of the principal. But in reality, I was supposed to calculate it for somewhat more than 3 times of the principal or 4 times of the principal plus. So 3 times of the principal is what I'm looking for. 3 times, a little more than 3 times. So my answer wouldn't be 21.4 years. My answer would be 22 years in this case. 22 years in this case. So 22 years, and this is my final answer. Okay, I hope we are good. Let me move on. Okay, so this is another shorter formula, as the rate of interest doesn't change, and sum becomes multiple times. Okay, sometimes let's say 4 times and then 5 times in some sort of years. So this is nothing but um, a trick to find out the rate. Okay, I'll try to use the very conventional method instead of taking the shortcuts here, but if you really wish to understand the shortcut, I have given it on the screen. Okay, so a certain sum of money becomes 4 times in 12 years when invested in simple interest. In how many years will it become 10 times of itself at the same rate? Now you need to understand, it says 4 times of itself. That means there is a component of principal and there is a component of simple interest. So this is nothing but the principal and this is nothing but the simple interest. Our main focus is supposed to stay on the simple interest only. So the question further says, how much time would it take to how much time would it take to become 10 times of itself? If I'm talking about 10 times, it also means I have the concept of a principal being there, which is p, and I would also have the concept of there being a simple interest, which is 9 times of p. If I add both of them up, if I add both of them up, I get 4p, and if I add both of them up, I get 10p. So once this situation occurs where there is 10 there where there is 4p as well as 10p, in this sort of a situation, I can easily declare that the simple interest once is 3p, the simple interest in the new situation is 9p. Very clearly, I can say that there is a multiplication factor of 3 times. I can very easily say that there is a multiplication factor of three times. In the first case, the time was 12 years. If the principal is supposed to convert itself into 3 times, and the question is in how many years, that means a new time has to occur. If the principal was multiplied 3 times, the time would also be multiplied 3 times into 3. Okay. So it's basically 3 times. And the answer would come out to be 36 years. I wouldn't call this portion to be a shortcut, but this is a very standard ratio proportion question. Okay, this is a very standard ratio proportion question. You just need to focus on the simple interest instead of focusing on the amount. Had you focused on the amount, you would have gotten a very wrong idea that 2.5 times the principal is becoming 2.5 times. But that is not what we are looking for. We are only supposed to focus on the interest because over time, over time, the principal would remain the same, but the interest shall increase or decrease. Got my point? I'll move on. At a certain annual rate, rounded off to the nearest integer of simple interest, a sum of money becomes 9 times its original value in 21 years. By how much does the rate of interest change if the same sum of money has to become 12 times its original value in 25 years? Okay. So this question could be solved in a much easier manner had we used the formula which was given in the beginning. But as I've already said, that I would rather choose following the concept more than following the formula. Okay. The question says, at a certain rate of at a certain annual rate of interest, simple interest, a sum of money becomes 9 times its original value. 9 times its original value, it means there is a component of p and there is a component of 8p, which is the simple interest. And the time it is taking over here, 8p is equal to, there is p, there is a rate component, and there is a time component. Time component is 21 years upon 100. I hope this position where I have skipped a step, this position where I have skipped a step, you would be able to understand why did I do that, because SI is equal to PRT upon 100. That is all I did. By how much does the rate of interest change if the same sum of money has to become 12 times its original value? When I talk about 12 times the original value, that means there is a component of P and there is a component of 11P. I need to focus on 11P. 11P is supposed to be there. There is a P, there is a rate, and there is 25 divided by 100. I will first have to calculate the rate of interest over here, and then I will have to calculate the rate of interest over here. The gap which I find out in the rate of interest, that is what is going to be my final answer. Okay, so the gap what I find out over here is 800 upon 21. Yeah, so this is 800 upon 21 is the rate 1 that I'm talking about here. Okay, let me assume this to be rate 1 and let me assume this to be rate 2. The rate 2 that I can see over here is 25 ones are 25 fours are. This becomes rate 2 becomes 44%. Now, the gap between rate 1 and rate 2 has to be found out. If I talk about rate 1, the value of rate 1 is nothing but I'll have to do a long division of 800 against 21. Why am I doing it? Because the value is a little big. It will be better if I try to find out the accurate answers. This is this 63 and I get a 7 and I get a 17. Okay, this is 170. This is 170 that we're looking at. 21 8s are, yeah, 38%. 8 1s are 8, 8 2s are 16. I am here at 2. I am here at 2. So let me assume it to be uh 09, 38.09. Yeah, so 38.09 is my rate 1. Talking about rate 2 has already been mentioned over here as 44%. Now there is a supposed increase, and round it off to the nearest integer. It is already asking me to round it off to the nearest integer. So against 38.09, I can call it 38%, and the rate 2 remains intact. So here I can see that the difference between rate 2 and rate 1 is 6%, and the 6% is a positive increase. So the rate increased by 6%, and B is my final answer. All right, let's move on. So now we are at this concept where the principal becomes A1 in T1 years and A2 in T2 years. If you need to find out the SI, if you wish to find out the simple interest, we have to divide the difference in amounts and the difference in time. When you put them in the division format, that time you get the simple interest of 1 year. Okay, so we'll be following this method as well, but let us talk about the most foundational points which will be coming up in the next question. Okay, a certain sum amounts to 3640 is equal to principal plus simple interest, and 4060 same principal plus simple interest. This simple interest was gathered in 2 years, and this simple interest was gathered in 8 years. Okay, the simple interest was gathered in 2 years and the simple interest was gathered in 8 years. If I have two equations here, this one being the first one and the second one, and I subtract the first equation out of the second equation, or 2 minus 1, what do I get? I get um this is 60, and that would make a 300. 360 plus 60, 420. You would get 420 being equal to, the p would get cancelled, and I would get 6 years of simple interest. If I divide that, I would get 70 as my simple interest for 1 year. I've used the same concept which I've talked about over here. Okay, so I get the SI as 70 rupees for 1 year. If I apply the same thing in my first equation, that says 3640 is equal to principal plus SI for 2 years. The SI for 1 year is 70, for 2 years it's going to be 140. So 140 would be subtracted from here on the left hand side. It would give me 3500 as my principal. Once I have my principal with me, I can say that 70 rupees was the simple interest for 1 year. If I need to calculate the rate of interest, it can be calculated by the simple interest divided by the principal, and 1 year is in question, so I need not write 1 anywhere. This multiplied by 100, the two zeros go, this is 1 and this is 2. So my rate of interest comes out to be 2% per annum. The formula which I have discussed over here only gives you the simple interest. If you were following my method and could have created equation 1 and equation 2, I believe you were through with the question. Okay, you could have solved it easily, but you can take this method as well. This is something which you need to memorize. This here the on the next page This is something you can conceptualize. Okay, so it's your priority, it's your choice if you wish to conceptualize things or if you wish to memorize things. Okay, both the things, you just need to solve the question within a very reasonable time in the exam, right? Let's move forward. Same question. Sum of money at simple interest amounts to 750 in principal plus 3 times of SI and 825 in principal plus 4 times of SI. This is equation 2, this is equation 1. If I do equation 2 minus equation 1, I do equation 2 minus equation 1, I get 75 rupees as the simple interest. 75 rupees as the simple interest. 1 SI or 1 simple interest is equal to 75. 3 times of simple interest is equal to 225. Put it in the first equation. The first equation says that 750 is equal to principal plus 3 times of simple interest, which is equal to 225. If I subtract these two things, I get the value of P as 25 here and 5 here. So 525 would be my answer, right? Am I right with it? Yes, I believe so. So 525 is my final answer. Good enough? Let's move on. Now, we are now going to talk about compounding of interest. Okay, we're now going to talk about compounding of interest. There is something very interesting about compounding of interest. All the formulas which we get over here would not have compound interest alone. It would not have compound interest alone. It would always have the compound interest plus principal becoming the amount. Okay, it would always have the compound interest and the principal together becoming an amount. Why does it happen? Because after every interest cycle, the principal is added to the compound interest and a new principal is created. So this is the reason that after every interest cycle you get a new principal. Okay, because the previous one is added. That is why it is called compound interest. There is a very simple formula which is attached to it, which says if you need to find out the amount is equal to the principal multiplied by 1 plus r upon 100 raised to the power t, where a stands for the amount, p stands for the principal, r stands for the rate of interest which is annual in nature, and t stands for time period which is in years. Okay, so there is this component which I would like to tell you about. We are first of all going to assume that there is a 10% compound interest that we are talking about. Okay, this is nothing but a shortcut. This is nothing but a shortcut which we might need to apply in the upcoming questions. Whenever we have a 10% thing, what we have to do is we need to have a principal, we have to divide it by 10. Okay, we need to have a principal, we have to divide it by 10. Why do we do divisions by 10? The reason is that the compound interest rate that we are talking about, it needs to be divided by 100, and whatever outcome comes here we need to multiply it by t. Like 10% is the compound interest here. Okay, so 100 compound interest, 10% compound interest would be divided by 100. So in the case of 10% compound interest, the principal is divided by 10, and the principal is continuously divided by 10 equal to the number of years in question. Okay, equal to the number of years in question. I'll try to first of all give you the concept over here. We're assuming that there is a 10% compound interest. The time has been given as 2 years, and we need to, and the principal has been given as 10,000. Okay. So in this sort of a situation, we need to have the principal divided by 10 once, and then whatever output we get, we have to divide that principal dash divided by 10 one more time. What am I going to do here? My first output would be 1000 and my second output would be 100. Okay, because 10,000 divided by 10 is equal to 1000, and 1000 divided by 10 is equal to 100. If in this situation we have a time period of 2 years, we are going to use the coefficients of Pascal triangle and multiply it by 2 and multiply it by 1. This is going to give me my entire compound interest for 2 years. The answer would be 2000 plus 100 as 2100. Got it? If I say that the time is equal to 3 years and the situation is the same, I'm going to get a similar output, P upon 10, P dash upon 10, and P double dash upon 10. How would it turn out to be? It would turn out to be as 1000 in the first go, 100 in the second go, and 10 in the third go. What is going to be multiplied as the coefficient of Pascal's triangles? They are going to be 3, 3, and 1. It's going to come out as 3,310. Okay, 3,310. This is going to be my compound interest. Okay, this is going to be my compound interest. If we talk about time being equal to 4 years, at that time we will have this exercise 4 times: P by 10, P dash by 10, P double dash by 10, and P triple dash by 10. In this particular case, what would it amount to? It would amount to this, that 1000 would be the first entry, because 10,000 divided by 10 is 1000. Then against 1000 I would get 100, then against 100 I would get a 10, then against a 10 I would get a 1. I'm doing nothing, I'm just dividing things by 10. Okay, I'm doing nothing but just dividing things by 10. Now the coefficients of the Pascal triangles which I need to have with me are 4, 6, 4, and 1. Okay, when I do it, I get 4641. 4641 as my compound interest. So this was the short trick that I was talking about, that every time you have to create or you have to calculate the compound interest, you can definitely take this route. But the only problem is that, let's assume there is a power of 5 and you get only a simple 10% interest. You get a simple, when I say simple, I should rather say you get an easy 10% interest rate. So once that comes into play, at that time you will have to have this sort of a problem: 1110 upon 100 raised to the power 5, if it comes out for 5 years. So in this situation, this thing helps you a lot. Okay, this thing helps you a lot. Now I would be solving this question here on the left hand side. Rahul invests two equal sums of money at compound interest under two schemes A and B. This is scheme A, this is scheme B. The interest rate was 10% per annum, and under scheme B the interest rate was 10% per annum. This is 10% and this is 12%. The compound interest after 2 years on the sum invested on scheme A was scheme A compound interest was 1050. And how much is the interest earned under scheme B after 2 years if the interest is compounded annually in both the scheme? Okay, so I am getting a 10% rate of interest in scheme A and 12% rate of interest in scheme B. The compound interest after 2 years for scheme A was 1050 and the time was 2 years. How much is the interest earned under scheme B after 2 years? the time is again going to remain the same, that is 2 years. If the interest is compounding annually in both the schemes, I need to find out the compound interest in this case. So I would start off simply with this, that amount is equal to compound interest plus principal. But the amount in the term of compound interest is also equal to the principal multiplied by 1 plus the rate of interest upon 100 raised to the power of time. This is the same formula that we've learned over here. I'll put the formula over here, and I would also put in the values that I already have with me. The amount is equal to P times P is something that I would get from this equation. 1 plus R is 10% upon 100 whole upon T is equal to 2 is equal to yeah, this is the amount which I have. The compound interest has been given as 1050 plus the principal has been already given to me. What is the principal? No, the principal is something which I need to find out. I'll quickly solve this. From here I would get the value as 11 upon 10 to the power 2 multiplied by P is equal to 1050 plus P. The P should come here on the left hand side. This turns out to be 121 upon 100 P minus P is equal to 1050. Okay, this would give me 21 P upon 100 being equal to 1050, and the value of P, which is same in both the cases, is going to come out as 5000 rupees. Okay, as I'm right now sure about there being a principal of 5000 rupees, I have to apply the same thing over here. I need to find out the compound interest. I would not be able to find out the compound interest alone. I would have to find out the amount. Okay, I would have to find out the amount. The amount here comes out to be 5000, which is the principal, multiplied by 1 plus 12 upon 100 whole raised to the power 2, because T is 2 years over here. I'll quickly solve it. 5000 multiplied by this thing should be squared, no? Yeah, this entire thing. 112 upon 100. When I divide it by 4, I get it as 28 upon 25 square. Same 5000 multiplied by 28 into 28 whole upon 25 into 25. 25 ones are 25, 25 200s are 50, or 5000, 25 ones are 25 eights are. Now 8 needs to be multiplied by 28 square. The square of 28 is 784, and the final answer which I get over here is 8 4s are 32, 3 and 8 8s are 64, 67, 6, 8 7s are 56, 56 plus 6 is 62. So I get the amount to be equal to 1272. The amount has a component of principal as well as a component of compound interest in it. So 5000 when subtracted out of the total amount gives me a compound interest of 1272, which is the final answer that I'm looking for. Okay. Okay, I hope you're able to understand whatever I did over here. If not, please pause the video, watch it one more time. Okay, I'll be moving on. Okay, 7205 are invested in a scheme of compound interest compounded annually. If the rate of interest is 20% per annum, then what is the interest earned in 1 year? This is not a great question. I really wanted to see a really good question over here. But nevertheless, I'll just see what goes on here. Huh. Okay, I already have my answer over here. There is a reason to it. Why it's talking about 1 year, I'll try to, yeah, I'll solve the question in the same manner. I'll use the compound interest formula. The compound interest formula says that A is equal to P multiplied by 1 plus R over 100 whole raised to the power T, T being the time, R being the simple interest rate, P being the principal, and A being the amount. I need to find out, what do I need to find out? If the rate of interest is, then what is the interest earned? So I basically need to find out the compound interest. There is a small twist over here. I am compounding the interest annually, and the year or the time period that has been asked in the question is only 1 year. I've told you in the past that the compound interest and the simple interest remain the same for the first year. Okay, the compound interest and the simple interest remain the same for the first year in cases where the time period is 1 and the compounding frequency is also 1 year. Okay, the time is also 1 year and the compounding frequency is also 1 year. Had the time been 1 year and the compounding frequency had been 6 monthly, it would have changed the equation. Okay, it would have changed the equation. So I'll quickly use this formula and go ahead. There is an amount investment of 7205. Okay, and uh, the rate of interest is 20%. That would give me 1 plus 20 upon 100 whole raised to the power 1, right? So 7205 multiplied by 6 upon 5 raised to the power 1. Similarly, I will have to quickly multiply things now. 5 ones are 5, 5 fours are 20, 5 fours are 20, 5 ones are 1. Multiplied by 6. What can I really see here? That whatever was being done over here is the complete value. If I multiply it by 6, I get what do I get? I get this amount with me, 8646, and this is the amount which also contains a compound interest in itself. This is the amount which contains principal plus compound interest. When I have such an amount, I quickly subtract it from the principal itself. I would subtract 7205 from this value and I would again get 1411. This is nothing but my CI because this is P. This is the principal. So 1441 is going to be my final answer. Right? So I hope everybody understood it. Let's move to the next question. Okay. When the interest is compounded half yearly, what happens is that the time period, let's assume in this case, is equal to 1 year, and the compounding frequency has been changed to 6 months. What does it actually do to your question? In this particular time, the time period, it doubles. Why does it double? I have to have a 12-month period, and I am doing the compounding on 6 months basis. So 6 ones are 6 twos are. This would give me a 2 times of 1 year. This would give me a double time period. What about the rate of interest? The rate of interest, I am the standard point of rate of interest is 12 months, but I'm doing it over and over. I'm charging the entire rate of interest in 6 months. That means this is 1 by 2. This means the rate has to be half. Okay, the rate has to be half. So these are my two deductions, or these are my two concepts, that 2 times becomes the time period and rate of interest becomes half. Okay, the rate of interest becomes half. Okay, I hope you have understood it. Nothing else changes, only the time period and the rate of interest changes corresponding to the main question. Okay, let's move on. A sum of money was invested at 10% interest per year, compounded half yearly for 18 months. If the amount payable on maturity was 83349, what was the sum invested? Okay, we have already been given the amount as 83349. I need to find out the principal. The principal has to be found out. Before that, there is a compounded half yearly clause which which gives you 18 months of time. Okay, which gives you 18 months of time. When I say compounded half yearly, this gives me an indication that I have 18 months of time and I am doing a 6 monthly period, which gives me 3 times of compounding cycle, which gives me a 3 times of compounding cycle. Similarly, I have 10% per annum. I have 10% per annum, and for a 12-month period, I am doing 6 month shows. Sorry, for a period of 6 months, for a period of 12 months, I am charging every 6 months. So half the 10% changes itself into 5%. So how does this change? This changes in the manner that I'm using the formula A is equal to T multiplied by 1 plus R over 100 raised to the power T, where the principal needs to be found out. The amount of 83349 is already available to me. The principal needs to be found out. I multiplied by 1 plus 5, 5 and 100. The time, it becomes 3. Okay, the time cycle becomes 3. So here I get principal multiplied by 21 over 20. This entire situation gets a power of 3, and 83349 is something which is left on the inside. The principal again would come out to be 20 multiplied by 20 multiplied by 20 whole upon 21 into 21 into 21 multiplied by 83349. Okay, from here I can see many factors of 7. 7 threes are 21, or should I go for 9 directly? Let me go for 9 directly. 9 nines are 81, I get 23. 9 twos are 18, I get 54. 9 fives are 45. 9 six are 54. Yeah, 9 6 are 54, and 9 ones are 9. So I have already gone for 9. So I'm left with 7 into 7. Let me go for 3 one more time. Yeah, 3 would be good. So I will let 7 into 7 be here. 3 threes are 9. 3 eights are 24. And 3 sevens are 21. I'll quickly use this. 7 fours are 28. 7 fours are 28. 7 ones are 7. Am I fine when I do it? Yeah. 7 ones are 7. 7 6 are 42. 7 threes are 21. 7 ones are 7. 7 nines are 63. I get 8,000 into 9, which is equal to 72,000 rupees. This is nothing but my principal. Okay. This is nothing but my principal. I hope you were able to understand the question, how the equations are made, and how finally things are solved. Right? Good enough? Let me move on. Yep. If 10% per annum rate of compound interest compounded yearly is equal to X percent X percent per annum rate of compound interest compounded half yearly, then what is the approximate value of X percent? Or what is the approximate value of X? So this is a really interesting question. So now in this particular question, what we have with us is that against a compound interest of 10% being compounded yearly, there is supposed to be another compound interest which is being compounded half yearly. So what happens over here is, if I'm talking about only a single year, if I'm talking about 1 year, I'm talking about 10% compound interest, then the simple formula would be, my simple answer would be 10% simple interest, which is also equal to 10% compound interest, because we're talking about 1 year. But this interest now, out of the four options, they have to be broken down in two portions. one being A, the other one being B, and then in the end, the last interest being A into B upon 100. Okay, so this is what it is supposed to be: A plus B plus A into B whole upon 100. And it is a half yearly compounding. That means it would be compounded twice. It would be compounded twice. In that case, both the rate of interest would be same. Let's assume they are A only. So that is A plus A into A square upon 100. Okay, so this is supposed to be equal to a 10% compound interest. The values are supposed to match on both sides. If I do it again, I get 2A plus A square upon 100 being equal to 10, and when I follow it up, it becomes 1000 being equal to 200A plus A square, or it simply being A into 200 plus A is equal to 1000. Okay, in such a situation, now you need to find out the value of A. I have four options over here with me. If I have A's value to be equal to 5, this multiplied by 205, what I get is 5 5s are 25 and 5 2s are 10, 1025. 1025 is not equal to 1000. So I can't have any of the values which is greater than or equal to 5. That means in this equation, I need to have a value which is less than 5. What if I go for 4.55, or I simply start with 4.5? 4.5 multiplied by 204.5. This would give me a 9 by 2 multiplied by 204.5. Now, this is 9 5s are 45, 4, 9 4s are 36, 40, 9 2s are 18. 18405 whole upon 2. This would give me 9205, and there is a point also involved. Okay, so there is a point which is also involved. So 9205 or 920.5 is not equivalent to 1000. That means a little more than 4.55 would be required. That means 4.88 stands to be my correct answer in this situation. Over here, this is a 10% question and all the values seem to be similar. So I would recommend everybody to follow it up, to just quickly learn it. Let the answer be 4.88 and quickly learn it, because it would be difficult for you to solve this question in the examination, because you will have to check each and every option in it. So quickly learn. If there is a 10% per annum rate of compound interest and its equivalent half yearly interest is going to be 4.88%. It cannot be directly 5% because the value is going to change. Okay. So here we were talking about the interest rate being compounding half yearly or annually. Now we'll have the concept of interest being compounding quarterly. Okay. The interest being compounding in a quarterly manner. What would happen in a quarterly manner? The rate would become one fourth and the time would become 4 times. Okay. Or 4 times, or I should rather say 4 cycles. Okay. That's a quarter, one fourth or 4. So here's the question: what is the compound interest on 8,000 rupees? That's our principal. In 3 months, if we have 12 months in a year and we have a compounding quarterly, we will have to divide it by 4. That means 3 months would be equal to 1 cycle. So it's basically asking us the rate of the compound interest for 1 cycle. Okay, it's asking us the compound interest for 1 cycle. Compound interest for 1 cycle or simple interest for 1 cycle, both are the same. So it's basically asking us to um, it's basically asking us to give you 8,000 multiplied by 3 months, that is one cycle, so I can multiply with 1 here, and 5% per annum is the rate. So I'm basically again calculating a simple interest which is in my favor only, because both the things are going to be the same. The percentage is gone because to the like reason the 100 in the denominator. 5 eights are 40, so 400 rupees would be the compound interest that I would be paying quarterly if the time period is only 3 months. Okay, if the time period is 3 months. So I hope everybody was able to understand this. We'll be moving to the next question, where again the compounding is in quarterly fashion. Find the amount of rupees for 1 year at the rate of 16% per annum if the interest is compounded quarterly. Now we are supposed to do it in 4 cycles. Okay, we are supposed to do it in 4 cycles. So if we are supposed to do it in 4 cycles, we have to divide it by 4. That would give me a 4% interest rate, right? That would give me a 4% interest rate. If you remember, I have already given you a method of using Pascal's triangle, the 4 6 4 1 method. If I have 4%, 4 upon 100 would give me 1 upon 25. 1 upon 25 becomes a factor which has to be multiplied by the principal successively so as to reach the final amount. And 4 6 4 and 1 are the multiplicative coefficients. These are the multiplicative coefficients. So what I'll do is I'll quickly put a 25 over 7500, 75,000 first. 75,000 upon 25 would give me 3,000 in the first go. Okay, so 3,000 would come here. Further, another 25 would give me a 1200, no, a 120. Yeah, it will give me a 120. Another 25, 120 upon 25. This is 5 5s are 25, and this is 5 24s are. So 24 upon 5 would give me a 4.8, and again a 4.8 upon 25 into 4. I'll do a 24 into 4 here and into 4 here. So this would give me what? This is going to be 1,000. This is going to be 1,000, and here I introduced this new zero because of the 4.8. I'm going to remove. I have removed the point. Okay, so 4 8s are 32, and 4 4s are 16. 192. So 0.192. 0.192. Now I will have to add up all the parts. I'll have to add up all the parts. I need to find out the amount. Okay, mind you that I would have to find the amount. So it is going to be 12,000. This is going to be 720. This is going to be 19.2, and this is going to be 0.192. Okay, so I'll add this entire situation here. This would give me a 92, a 392, and a 9 here, and a 3 here, a 7 here, a 2 here, and this here. So my compound interest is nothing but 12739, and everybody has rounded it off to 2 decimal places, so I would do the same. 0.40. I have to find out the amount in this situation. The amount is 75,000. So the 75,000 would be written on the top. This is the principal. Principal plus compound interest is equal to the amount. And the amount in this case is 87739.40. So this is my final answer. Okay, I hope you were able to understand this coefficient thing. What really happens is, I'll tell you. Now I'll conceptually explain you the question. I won't be solving it anymore, okay? Because the solution is here in front of you. Find the amount of 75,000 rupees for 1 year at the rate of 16% per annum if the interest is compounded quarterly. They are talking about 1 year over here. They are talking about 1 year over here, and they are saying that out of 12 months there has to be a compounding. Okay, there has to be a compounding, and the compounding is supposed to be done 4 times in a year. Quarterly means once in every 3 months. Okay, so 4 ones are 4 and 4 threes are 12. This means every 3 months I need to do a compounding. When I'm doing a compounding every 3 months, that means in a cycle of 1 year, I'm doing compounding 4 times. Whenever you see a compounding factor of 4 times, you will have to write these coefficients 4, 6, 4, 1 straight away. Then you have to find out the factor which needs to be multiplied with the main principal. The main principal is 75,000 over here. The factor which we came up with, because the interest rate was also supposed to be divided by 4, the interest rate was also supposed to be divided by 4. So that's why 16% was divided by 4. 4% came out to be the quarterly rate of interest. The quarterly rate of interest. Now, this quarterly rate of interest was to be applied in a cycle of 3 months or in a cycle of 4 times. That is why, according to the Pascal's triangle, 4641 would be the coefficient. 4641 would be the coefficient. And the multiplying factor I would get would be 1 upon 25. This 1 upon 25 would be successively multiplied with the main principal. The main principal being 75,000. The first time it is divided by 25, I get a 3,000. I write that 3,000 over here. Then I again do a division by 25, I get a 720. Another division by 25, I get a 19.2. Another division by 25, um, I get a, sorry, another division by, just a second. 3,000 divided by 25 would give me a 720. 120 divided by 25 would give me a 4.8, and 4.8 divided by 25 would give me a 19.2. Okay, so in this situation I have just done simple multiplications, and in the end over here I've done a simple addition. This brings me to a point where the compound interest has been found. Okay, we have the compound interest with us. As we have the compound interest with us, what do we need to do? We need to add that compound interest with the principal. That would give us the final amount that has been asked in the question. Okay, I hope you understand it very well now. If you still have doubts, do write in the comment section. Okay, I'll be moving on. When the interest is compounded x monthly, the rate of interest comes down to 1 by x of its time, and the time period becomes x times. Okay, this is a simple analogy. A sum of x rupees amounts to rupees 1 to 777.60 in 2 years at 15% per annum. When he when the interest is compounded, this is the interest. Okay, when the interest is compounded 8 monthly, find the value of x. See, the interest is being compounded 8 monthly, and there is a 15% interest rate. I will have to find out r dash, which is the new interest rate. So this is 4 2s are 8, 4 3s are 12, 3 5s are 15, and the rate of interest comes out as 10%. As the time is 2 years, this means the time is 24 months. If 24 months is the time and there is an 8 monthly compounding cycle, I have to follow 3 cycles. So 10%, 10%, and 10%. In 10%, if I follow this cycle, my answer would come out to be 1 upon 10 upon 100 multiplied by the principal. This would have a degree of 3. This is nothing but the compound interest formula which I'm using here. So this is going to be 1 to 77760 upon 100. Simple. After solving this, I would get 11 upon 10 raised to the power 3 multiplied by the principal. The principal is what I have to find out. Okay. 1 to 777 6 upon 10. The principal here becomes 11 into 11 into 11 whole upon 10 into 10 into 10. This is a multiplication sign here. 1 2 triple 7 6 upon 10. The 10 gets cancelled. I start with 11. 11 ones are 11, 11 ones are 11, 11 6 are 66, 11 ones are 11, 11 6 are 66. Another 11, 11 ones are 11, 11 fives are 55, 11 6 are 66. Am I? Yes, there is a trouble. There's a zero missing. Okay, similarly, 11 nines are 99 and 11 6 are 66. So the principal upon 100 is equal to 96. Therefore, I can say the value of the principal is 9600 rupees. Okay. And if you sometimes find that the number of zeros is an issue, then you need to understand this thing, that the final amount is 12,000 something. So the initial amount cannot be 960 rupees. The initial amount also cannot be 96,000 rupees, because the final sum has the amount as well as the principal. The final sum has the compound interest as well as the principal attached to it. So 9600 seems to be a reasonable figure. That is why whenever you are stuck in the zeros, try to understand where the question, or what is the ballpark figure we are looking for. The ballpark figure we are looking for is somewhere around 13,000, a little less than 13,000. So 9600 is going to be my final answer. Right? Okay, I'll move on. What is the difference between the compound interest? When the interest is compounded 5 monthly and the simple interest on a sum of 12,000 for 1 by 4 years at 12% per annum. Okay. Firstly, there is a 12% interest against against the time, the total time, or the total number of months is 12, and the total time we are talking about is 5 month. The cycle is a 5 monthly cycle, so this entire thing gets cancelled, and 5% comes out to be my rate of interest. Okay, 5% comes out to be my rate of interest when I'm talking about compounding things on a 5 monthly basis. And the total time period which comes out here is 1 by 4, which is equal to 12 months plus 3 months, or 15 months. 15 months divided by 5 months, this gives me 3 cycles. Okay, this gives me a time period of 3 years, or I would rather say 3 cycles. I have the rate of interest with me, the new rate of interest with me, the new time with me. I would first have to find out the compound interest. There is a very interesting thing which we can do here, but shall we do it or not? Let me understand that. It can be done right now. It can be done. As I already have the rate percentage, I know that I have to have a successive rate percentage of 5% plus 5% plus 5% over a period of 3 years. Okay. On the other hand, if I talk about 15 months, if I talk about 15 months upon 12 multiplied by 12%, I have a very R double dash being the simple interest. Okay, this is the simple interest and this is the compound interest. I would put them in circles. This is the simple interest we are talking about over here, and this is the compound interest that we've talked about already. The 555% which you have over there is successive in nature. It's successive in nature. On the other hand, the 15% that we get over here is simple in nature. Okay, it's simple, one short thing. Simple, one short thing. So we have successive as well as simple. So in this situation, we would do the successive percentages calculation, which goes in this manner, that when 5% is done with 5%, I'm using this formula. Okay, I'll write the formula here: a plus b plus ab whole upon 100. Okay, this becomes the successive calculator for us, and 5 into 5 whole upon 100. So this gives me 10.25. This 10.25 would have to be done with another 5%. Okay, I have put the wrong symbol. It is supposed to be a plus sign. It is supposed to be a plus sign. So 10.25 plus 5% plus 10.25 into 5 over 100. Okay. Whenever in such a situation, do not try to cancel out the 100 which is in the denominator. Do not try to cancel out the 100 which is in the denominator, because in the end we will be piled up with more calculations. It's better to multiply 5 with 10.25 and simply get the answer in decimals, right? So 10.25 plus 5% makes it 15.25, plus there is a new factor which is coming up. This is 5 1 2 5. The point is here, the point would move here, 0.5125. This would make it 7625. So this is 15.7625. The R double dash is 15%. The R dash which we have calculated finally is 15.7625 percentage. Okay, this is simple, and this is for compound. See, there are so many facets, there are so many faces that you see of compound interest. The first way is to use successive percentages to find out the final compound interest, which you can multiply with the principal in order to find the real compound interest. Similarly, you could use the formula that principal has to be multiplied with 1 plus r divided by 100, whole thing to the power of t, equal to the amount where you can achieve the amount. And the other way would be to simply do the 4641331 or 2 1 method, the one which I talked about in the Pascal's triangle scene. Okay, I've talked about the Pascal's triangle over here. If somebody has just joined, they may have a look of about that here in the first few slides. I think in the first 3 4 slides I've talked about Pascal's triangle. Where did it go? Just a second. No, when we started off the compound interest chapter, that is the time where I talked about Pascal's triangle. Yep. This is the point where we've talked about Pascal's triangle over here. Okay. This is the 2 2 1 thing. 2 1. This is the 3 3 1, and this is the 4 6 4 1. This is particularly for 2 years. This is for 3 years, and this is for 4 years. Instead of saying it years, I can also call it 2 times, 3 times, and 4 times for the ones who are now very well versed with the concept of um, compounding on a monthly, quarterly, or a bi-annually basis, okay, or a 6 monthly basis. So for them, this is how it will go. I'll quickly come back to the question where I was standing here. The difference in the two interests which I can see, it is 0.7625 percentage. This difference can be applied to the 12,000 what we have in the bag. Okay, this can be applied to 12,000 what we have in the bag. 3 zeros would be gone. The point would come somewhere here. Okay, after the 3 zeros go, the point would come somewhere here. I'll quickly multiply it by 12. 12 5s are 60. 6 in the air. 12 2s are 24. 3 in the air. And 12 6 is 72. 5 here and 7 in the air. And 12 7s are 84. 84 plus 7 is 91. Okay, so this is it. I have 3 zeros. Yeah, I have to, this is supposed to be 91.5 rupees. Okay, this is my final answer. Were you able to understand how the successive percentages help us to achieve the rate percentage as quickly as possible? So this is what I was talking about. Moving forward, a sum invested at compound interest amounts to 7,800 in 3 years and 11,232 in 5 years. What is the rate percentage? So I'll be following the regular formula that the principal has to be multiplied with 1 plus rate over 100 to the power times being equal to the amount. In this question, what we have here is amount 1, time 1, amount to time 2. The principle is the same. Whenever we get a situation where the principle comes out to be same, we can go for a simple division. That would lead us to a very good path. Okay, that will lead us to a very nice place. Let us try to do that. The principle in the first case has to be multiplied by 1 plus r over 100 multiplied by 3 years in time, and the amount is 7800. In the second case, the principal has to be multiplied to 1 plus r over 100 to the power of 5, and the amount comes out to be 11232. These two equations have to be divided. Okay, these two equations have to be divided. When the two equations are divided, I am left with 1 plus r over 100. This entire situation goes for a square. Okay, this entire situation goes for a square, and 11232 over 7800. This is a square. We need to find out something which might take us to a square root. Okay, I'll quickly use the table of 13. 13 6 is 78, 600. 13 7s are 91, 13 8s are 104. Yeah, so 13 8s are 104. 83, 13 6 is 78, 13 4s are 52. Shall I use the table of 6? I think yes. This is 100. This is 6 1s are 6. This is 6 4s are 24. This is 6 4s are 24. So what I'm able to achieve is that 1 plus r over 100 when squared would give me 144 over 100. Applying square root on both ends, what do I get? 1 plus r over 100 being equal to 12 upon 10. Now in this situation, I can say that the baseline value is 10 and the final rate percentage which come with the final amount which comes out is 12. So I can see a gap of 2. The base amount is 10. When I multiplied this by 100, I get to know the rate percentage, which is nothing but 20%. Okay, so this is my final answer. Right, let's move on. A sum of 7500 amounts to 15,000 in 2 years. Compound at compound interest calculated annually. How much time, or how much would 7500 become in 4 years? In such a situation, whenever there is a component of time involved, we see that the number of times amount becomes is equal to the power of time, or I should rather say the exponent of time. So here 75,000 7,500 is becoming 15,000. The number of times that is coming here is 2 times, and it is taking 2 years for this transaction to take place. It's taking 2 years for this transaction to take place. If another 2 years is applied to it, if another 2 years is applied to it, or if another 2 years is applied to it, then the same multiplied by 2 thing would come into place. The same multiplied by 2 thing would come into place if another 2 years is given to it. If for the first 2 years there was a double in the sum, in the next 2 years also there would be a doubling of sum. That would create 30,000. So this is my answer, that the sum in the next 2 years again, it would become 30,000, double of itself. Okay, so 75,000 in 4 years would become 4 times of itself. Right, I hope we are good. Yep. Okay, let's move ahead. A sum invested at compound interest amounts to 8,000 in 4 years and 8,400 in 5 years, interest being compounded yearly. Okay. What will be the amount of the same sum at the end of the 6 years, of the sixth year? Okay. So I will be using the standard formulas in this. We have a component of 4 years. There is this situation of 1 upon 1 plus r upon 100 raised to the power 4 years. I will call this thing, there is a principal, and this is amounting to 8,000 rupees. Then there is a principal 1 plus r over 100 raised to the power 5, which is becoming 8,400. That means when I divide the two equations, I get 1 plus r over 100 raised to the power 1 as 8,400 upon 8,000. The two zeros would get cancelled. I would get a 21 when I use 4, and I would get a 20 when I use 4 here. So 1 plus r over 100 is 21 upon 20. So I can easily see that the rate percentage is equal to 5%. The rate percentage is equal to 5%. When I say that the rate percentage is equal to 5%, what will be the amount of the same sum at the end of the sixth year? Now, I can easily find out the principal from this situation. If I'm trying to find out the principal from this situation, it would become 21 over 20 raised to the power 4 being equal to 8,000. The question being asked is p raised to the power 21 upon 20 raised to the power 6 is equal to what value, right? So I'll first solve this one. This means that 8,000 into 20 raised to the power 4 upon 21 raised to the power 4. I'll apply this value over here. I'll apply this value over here. I'll use the principal from right to left, and that would be 8,000 into 20 raised to the power 4 upon 21 raised to the power 4 multiplied by 21 raised to the power 6 divided by 20 raised to the power 6. The powers would get cancelled. This entire situation would cancel it to 20 raised to the power 2. This entire situation would also make it 21 raised to the power 2. This means 8,000 would be divided by 400 and multiplied by 441. The two zeros go, the 4 makes it a 20, and the final output comes out to be 2 ones are 2, 2 fours are 8, 2 fours are 8. So my final answer is nothing but 8820. Okay, so my final answer is nothing but 8820. I hope that is enough. I hope that is understood by everybody. Okay, so I'll be moving ahead. A sum becomes 33800 in 2 years and 43940 in 3 years when lent in a scheme of compound interest compounding annually. If double the sum was invested in the same scheme for 2 years, then what will be the amount obtained at the end of 2 years? Okay. Yeah. So here what we'd be doing is we'd be plugging the values in the question. The principal, which hasn't been given to us, multiplied by the rate to the power of 2. Okay, so this r to the power 2 is nothing but 1 plus r upon 100. Okay, so I'm using r instead just for a while. Okay, r to the power 2 is equal to 33,800. Again, when principal is multiplied by r to the power 3, I am getting 43940. I have equation 2, I have equation 1. I would divide equation 2 by equation 1. I'll put a circle around it so as to represent them as equations. Okay. From that, I would get the value of r being equal to 43940 divided by 33800. Okay, I'll cancel out the 2. Then, um, shall I start with 2? I think we should go with 2. Or how about 13? 13 threes are 39. No, 2 is good, I think. Okay, 2 ones are 2, 2 six are 12, and 2 nines are 18. Then 2 twos are 4, 2 ones are 2, 2 nines are 18, 2 sevens are 14. 2197 is the cube of 13. So this is, um, 13 ones are 13, then 89, 13 6 are 78, 6 are 78, and 117, 13 nines are 117. So I remain with 13 here, and this is basically not 169, this is 1690. So I have a 130 here, then this is 10, and this is 13. So from here I can conclude that r is equal to 13 upon 10, or in a simpler manner I would write that r is equal to 1 upon r upon 100, which is equal to 13 upon 10. What do I get out of it? Against this I can understand that my rate percentage is equal to 30%. So this 13 upon 10 can be used multiple times. First of all, uh, let me quickly find out the the value of p. Let me quickly find out the value of p. I think I have some option here. If the double the sum is invested in the same scheme from 2 years, I think we have a direct answer here. 33800 can be multiplied by 2, which would reach 67600, and this would be the answer. Why? If you read the question a little more thoroughly, you'll understand that a sum becomes 33800 in 2 years. If the original principal is made double and the same scheme is applied for 2 years, then what would be the amount obtained? As there is no coefficient of p which comes extraneously, which comes from the external side into the question, that means any operation which is done on p would directly reflect on the outcome. So 33800 simply multiplied by 2 would give me the same answer. Okay, so I'll still follow the longer route and come down to a conclusion. So I have p over here. I'll be using r square. Which is 13 over 10 and 13 over 10, and I would write it as 33800. I'll use it. This is 13 into 13, 169. This is twice of 169, so this becomes 200, and another 2 zeros go there, so the principal comes out to be 20,000 rupees. Now this principal of 20,000 has to be converted into p dash, which is equal to 40,000 according to the question. They're asking that the double of the sum has been invested, so this 40,000 now would be subject to a 30% increase over 2 years. That would make it 4 times 0 multiplied by 169 whole upon 100. The two zeros would go. 4 is supposed to be multiplied by 169. But if I multiply 17 fours, I get 68. Okay. So 17 fours are 68. 174 is 680. 680 minus 4 is 676. So 67600 is my final answer. And somewhere in the middle, I had this revelation that 33800 is the principal which has been increased because of compounding. If the principal is supposed to be made twice of it, that means the amount can also now be made twice, because there is no factor which is altering or appreciating the value of the principal in the equation. Okay, so there is no factor which is alongside p which is fiddling with the value of p. That is why a simple multiplied by 2 would have also given us the same answer. Okay, good enough. Let's move on. So this is a little interesting. When we have to find out that the sum has changed, the future sum has changed, What we have to do is we have to give the present sum a treatment of T2 upon T1. Okay, T1 is the new time, T1 is the old time, T2 is the new time, T1 is the old time. Okay, new time and old time. So we'll be using this formula because this is really easy. Okay, so first of all, I'll find out what is the time and what is the times. Okay, this is the multiplication factor, this is the multiplication factor, and this is a time factor. If a certain sum is compound, if a certain sum at compound interest becomes 2.5 times in 5 years, then how many years will it take to become 6.25 times at the same rate of interest? So what we learned over here, we learned that the value of 6.25 is equal to 2.5 raised to the power t2 by t1. Here t2 is x and t1 is 5. Okay, t2 is x and t1 is 5. Now I can clearly see that 6.25 is the square of 2.5. So 2.5 square is equal to 2.5 raised to the power x over 5. Similarly, x over 5 is equal to 2. This would create a value of x being equal to 10, because when the bases are same, then the powers are equal when they are divided by an equal sign. When I say divided, I mean to say when they are expressed in an equation. At that time, when the bases are same, then the powers are equal. So the value of x is 10. Hence, the same rate of interest. And how many years? The answer is 10 years. Okay, good enough. Let me move on. Similarly, a money is doubled in the bank account in 7 years. Okay, so n means the money is being doubled. The time is 7 years. What time in years is needed to make an amount 8 times in the bank? 8 times the amount is required, and x time has been asked. So the value of 8 is nothing but 2 to the value of x divided by 7. I can easily say that 2 raised to the power 3 is equal to 8. So 2 raised to the power x by 7 is equal to 2 raised to the power 3, which similarly comes to x upon 7 being equal to 3. So the value of x is nothing but 21 years. As simple as that. Okay, 21 years, as simple as that. Good enough. Let's move on. So, what is the difference between the compound interest for 1.5 years at 4% compounded yearly and half yearly? Compounded yearly and half yearly. First of all, I need to find out the rate of interest. This approach is the best approach. Why? Because you need not multiply the principal multiple times against the interest. It's better you find out the rate of interest first, and then we can talk about the principal in the end. Okay, so the rate of interest when we are talking about yearly, the rate of interest, we have 1 year and half a year. We have 1 year and we have half a year. For the first year, the rate of interest is going to remain the same, 4%. For the other half of the year, the rate of interest is supposed to half down because it's a half year. So 4 plus 2% is not going to be 6%. We have to apply successive percentages. So the value would be a plus b plus ab over 100 in terms of percentages. A plus b is equal to 6 plus 4 into 2 is 8. 8 over 100 is 0.08. So my percentage or the rate of interest for compounding on a yearly basis comes out to be 6.08%. Now compounding half yearly. When I'm talking about half yearly, I need to find out the total time that is being used. The total time being used over here is 18 months, and the compounding is being done 6 monthly basis. So 3 cycles have to be completed. Similarly, the rate of interest has to be reduced to 2% because 4% into 6 over 12, 6 months was the compounding rate and 1 year is the standard time, so 1 by 2, this gives me a 2% compounding. As 2% compounding according to 6 months, as the cycles are going to be 6 months each, this is 6 months, this is another 6 months, and this is another 6 months. This is going to be 2%, another 2%, and another 2%. I'll do two of them together. So 4.04% is the starting rate. Then bringing this 2% down here, this would give me 6.04% plus 808, another 0 here and a point over here. So this would give me 6.1208%. This is the value of R2. Let me call it R2. Okay, instead of calling it R dash, let me call it R2. Now I have R1 as 6.08%, and then I have R2 as 6.1208%. I'll quickly find out the difference between the two. The difference between the two would be found out by subtracting 1200, and this is 1208 minus 800. This would give me an 8 and this would give me a 4. This would give me a 0. So 0.0408. 0.0408. Now this would be multiplied by 10,000, which would give me 4 zeros, and my final answer would be 408 rupees. That would be the difference between the compound interest when I'm doing it for 1.5 years for 4%, 4% compounding. Okay, it should be 408 or 4. Okay, there's a percentage sign as well involved. So I would have another 2 zeros. So 2 zeros against 2 zeros would go. Only 2 zeros would shift. So this is going to be 4.08 rupees. I'm sorry. This is going to be 4.08 rupees. Because how did I come to that solution? Because if I'm talking about a simple 6%, the 6% is going to be 600 rupees. Okay. And on the other way, this 6.128% is also going to be 612 something something. So there's hardly a gap of 4 rupees, not 400 rupees. Okay. The mistake that which I was committing was that this was a percentage whose percentage symbol had to be removed. That is why in the denominator we had to put a 100. Good enough. Let's move on. What is the difference between the compound interest on 6400 rupees for 1 year at 5% per annum compounded yearly and half yearly? Okay, what is the difference between the compound interest on 6400 for 1 year at 5% per annum compounded yearly and half yearly? I have 5%. We are talking about 1 year. We are talking about 1 year. Let's talk about compound interest yearly, and let's talk about compound interest 6 monthly. So we have 6 months over here. For 1 year, the SI is going to remain the same as CI, and it's going to be a flat 5% thing. For 6 months, the rate of interest is going to change. It's going to halfen down. So 2.5% plus 2.5% plus 6.25 or 0.0625. Okay, because 2.5 square is 6.25 and another 100 in the division would give me 0.0625. So this is going to come out as 5.0625, and there is a 5.000 in the situation. Okay, so 0.0625. So this 0.0625 is going to be applied on 6400 rupees. 6400 multiplied by 0.0625. This is a percentage. To remove the percentage sign, we are going to have 100. Then we are going to have 4 zeros. Okay, we are going to have 4 zeros because we are removing the point as well. Now, to convert 625 into a whole number, what can be done is it can be multiplied by 16 directly and divided by 16 directly. When 625 is multiplied by 16, the answer comes out to be 10,000. If it is being multiplied by 16 directly, then we'll have to divide it by 16 as well. This 16 multiplied by 625 would give me a 10,000, which is directly going to get cancelled. And these two zeros are being cancelled off over here. So 16 ones are 16, fours are 64. So my final answer is 4 rupees. Okay, or 4 rupees. Why was this question interesting? The only reason was that we used successive percentages to find out the final value. Okay, it was we were using successive percentages to find out the um, the final value, and 5% is CI for 1 year. Okay, so that's why it was interesting. And the interesting calculation was when 625 is multiplied by 16, it gives us 10,000. If we are multiplying something by 16 in the numerator, we will have to divide the same thing in the denominator as well. Okay, so I hope this question is understandable and everybody is okay with it. Okay, I'll move on. Okay, so a person invests 55,000 for 2 years on compound interest such that the rate of interest for the first year is 8% per annum, and for the second year is 12% per annum, and the interest is compounded annually. What is the total interest earned by the person? So 8 plus 12 plus 8 into 12. We've already done it. That's why I'm not solving it a lot. Okay, this is going to give me a 0.96 and this is going to be give me a 20. So 20.96% is the official rate of interest that we are talking about. This 20.96 percentage would be divided by 100 and another two zeros, because this is a percentage. The sign removal would give me two zeros and the decimal removal would also give me two zeros. Now I have 55,000 in the equation. So these two zeros are getting cancelled here. The other one is getting cancelled here. This is 55 11s. This is 55. This is 5 2s. Okay, this is 5 11s. This is 5 2s. Now 2 would be multiplied by 1048, and this would give me answer as 8 88. This is going to be 12 and 1128 if I'm not wrong. This is 88. This is 44 plus 8 is 52. 44 plus 8 is 52. 11 zeros are 0, 11 ones are 11. 11528 is the interest. It is the interest that I'm earning. Okay, 11528. Got it? Okay, let me move on again. 3,000 is lent at a compound interest compounded annually for 3 years. If the rate of interest is 10, 20, and 30, what will be the total compound interest? Okay, so I have 10% firstly, second 20% secondly, and 30% thirdly. So 10 plus 20 is 30%, plus 10 into 20 is 200 upon 100 is equal to 2%. So that is equal to 32%, plus 30%. This would give me a 62%, plus a component of 30 into 32 over 100. 3 2 is 6, 3 3 is 9. Okay, so this is going to give me 69. No, just a second. This is going to give me 3 2 is 6 and 3 3 is 9. 9.6 percentage would be the one coming from here, because this is going to be 960 upon 100, which is going to come up to be 9.6%, and when both of them are added, this comes out to be 71.6%. This is my final compound interest for 3 years. Okay. Now I need to find out the total compound interest. Total compound interest means 30,000 is multiplied by 71.6 whole upon 100, that is of percentage, and another 10 for decimal removal. 3 zeros gone, 3 zeros gone. 3 is multiplied, this is 48, this is 21, and this is 0. 2148. 0 is my total compound interest. Okay, got it. Let's move to the next question. Now, now there can be situations when you find that the difference between compound interest and simple interest has to be found out when you have a principal given to you, the rate of interest 300 plus r would be there, and 100 and 100. So this is a standard formula which you can use throughout the upcoming questions. Okay, you'll get to understand them when I talk to you about them in the questions. Okay, I'll go ahead. The difference of the compound interest and the simple interest on a sum of money for 3 years is 186 rupees. Okay, 3 years is equal to 186 rupees. Okay, find the sum of money if the rate of interest in both the cases is equal to 10%. I'm talking about 10% over here. If I apply a 3-year SI on it, this comes out to be simply 30%. If I apply a 3-year compound interest on it, I would be left with 10 plus 10 plus 10, going two at a time. 10 plus 10 is 20. 10 plus 10 is 20, and 10 into 10 is 100. 100 upon 100 is 1. That makes it 21%. Bringing the last 10 from the top, this is going to become 31% plus 21 into 10 upon 100. This would give me 2.1%. This would be equal to 33.1%. So for the SI, I have the value of 30%, and for the CI, I have the value of 33.1%. Find the sum of money if the rate of interest in both cases is 10%, and the difference that we're talking about, the difference is 3.1% of the principal is equal to 186. The principal in this case would be 186 upon 3.1, and this would give 100 here, this another 0, 31 6. So the principal is equal to 6,000 rupees. Okay, the principal is equal to 6,000 rupees, and this is my final answer. Okay, moving on. Find the difference between the compound interest and simple interest for a 2-year on a sum of 11,000 at the rate of 11% per annum. Okay, 2 years, we have a situation of 2 years. The situation calls for 22% at simple interest, and talking about compound interest, I will do an 11 plus 11, 11 plus 11 plus 11 into 11 upon 100. This comes out to be 22 plus 1.21, which becomes 23.21. This is the compound interest. I have a gap of what? I have a gap of 1.21%, and the sum or the principal which I have is 11,000. This would be divided by 100 because I need to remove the percentage sign, and another 2 zeros to remove the decimal sign. So the 3 zeros get cancelled over here. The value comes out to be 1331, and there is a decimal which is required. So my answer is 133.1 rupees. I hope you're able to get what I'm talking about. I do the simple interest portion separately. I do the compound interest calculation separately. Okay. So once you have the rate of interest in your hand, at that time you only need to multiply it with the principal, and that's when you will get your answer. Okay. Good enough. I'll move on. Okay. The simple interest on a sum of money at 10% per annum for 2 years is 8100. That means the simple interest we are talking about for 10% per annum for 2 years means 20% of the principal is equal to 8100. The principal is going to be 8100 upon 20 into 100. This becomes 5. This becomes 5 ones are 5, 5 eights are 40. Yeah, 5 eights are 40. This becomes 40500, 40,500. This is nothing but my principal. What would be the compound interest on the same period at 15% per annum? We have to apply it for 2 years. I need to find out the compound interest rate percentage, which would be equal to 15% plus 15% plus the square of 15, which is equal to 225 divided by 100. This is equal to 30 plus 2.25, which is equal to 32.25%. I have my principal with me. I simply need to multiply it by 32.25. Okay. So I'll do this. 32.25 divided by 100 and another 100. One for the percentage symbol and one for the decimal, and 40500. Okay. I'll quickly get rid of the two zeros. I'll try to get rid of more zeros. Shall I or shouldn't? No, I don't think so. I should. I'll quickly write down 405 needs to be multiplied by 3225. So to simplify my calculation, I would once multiply it by 400 and I would once multiply it by 5, and then whatever results I get, I would add them up. Okay. For multiplying by 400, when 4 is multiplied by 225, I get the answer as 900. Okay. So I would get double zero. 1 is going to go there and this is going to be 9 and this is going to be 12,900. Okay. So this is when I multiplied by 4. Two more zeros are required. Okay. This becomes 12 lakh. This becomes 12 lakh 900. This is just for the time being. Okay. This becomes 12 lakh 90,000 rupees. 12 lakh 90,000 rupees. Once I multiply it by 5, what do I get? I get 5 5s are 25, 5 2s are 10, 12, 5 2s are 10, 11, 5 3s are 15, 16, 1 6, 1 2 5. When I add both of them up, what do I get? 1306125. I also have a component of 100 missing. So 13061.25 is my answer. You can round it off to the nearest integer. You can call it 13061 to be your final answer. Okay, good enough. Let me go ahead. Peter invested in a certain sum of Peter invested a certain sum of money in a scheme paying 10% simple interest per annum, while Rachel invested half of the sum that Peter had invested in a scheme paying 10% per annum compounded. Also, Peter invests for 2 years, and Rachel invests for 3 years. If the difference in the interest earned by Peter and Rachel was 897 rupees, what was the sum that Rachel had invested? This is a very, very interesting question. I would want you to pause the video and read it once. Okay, I'll talk about Peter and I'll talk about Rachel. The investment between Peter and Rachel has a very beautiful relationship. Peter is investing something and Rachel is investing double of that money. No, Rachel is investing half of the sum of Peter invested. Okay, so that means I can say that twice this is Pete, this is Rach. Okay, Peter is investing 2 times of P and Rachel is investing P. This is establishing the relationship that Rachel is investing half of whatever Peter is investing. Okay, 2P and P. While Rachel invested half of the sum, Peter invested in a scheme paying 10% interest per annum compounded annually. Peter is doing it for 2 years and Rachel is doing it for 3 years. Peter is investing at 10%. Rachel is also investing it at 10%. Rachel is going through a compound interest and Peter is going through a simple interest. Okay, let me quickly find out what amount um, or what is basically the simple interest of Peter. The simple interest of Peter stands at twice of P multiplied by 2 years time multiplied by 10% of interest divided by 10 divided by 100 to remove the percentage sign. This would give me 4P upon 10 to be the simple interest of Peter. We have been given a relationship between the simple interest or the interests earned by Peter and Rachel to be 897. So I'll go back to the compound interest that was earned by Rachel. For compound interest, I will have to do successive multiplication or successive percentages. So it would be 10 plus 10 plus 10 or 10 plus 10, which would make it 21. Then 21 plus 10 would make it 31 plus 2.1, which is equal to 33.1. So 33.1 P over 100. This is the value. This is the value which is being earned by Peter. Okay, so by Rachel. So the compound interest of Rachel is equal to 0.331 times P, and the simple interest earned by Peter is 0.4 times P. So I need to find out the difference between 4P and let's say 3.31P. I'm just assuming, okay? It can be 0.4. I just need to find out the difference between the two. The difference between the two stands at 69P or 0.69P in this situation. The value of 0.69P has been given as 897. Okay, so the value of P is nothing but 897 upon 69 into 100. This is 69 ones are again 69 ones are. This would get cancelled at 3. So there is a small defect. There is a percentage sign as well which was involved. So I'll put just another 0. So 13,000 is going to be my principal. Okay, it's going to be the value of P. I need not find the value of 2P because the question is asking me to find out the value of P. Okay, I hope I've made myself very clear. This was a very typical question and it was a good question. I really liked it. I'll move on. Okay, what is the rate of interest in simple interest if simple interest earned on certain sum of 3 years is rupees 6,000? That means if for 3 years the SI is equal to 6,000, for 1 year SI would be equal to 2,000. Got it? And compound interest earned for 2 years is compound interest earned on 2 years is 164160. If I talk about 2 years simple interest, I get it as 4,000 rupees. If I talk about 2 years compound interest, I get it as 4160 rupees. This means there is a gap of 160 rupees which was which arose due to the 2,000 rupee investment. So on a 2,000 rupee investment, there is a rate of interest which is being applied. I'm using it for 1 year divided by 100, which would give me 160. The 2 zeros get cancelled. The 1 zero also gets cancelled. The rate of interest in this situation comes out to be 8%. Okay, the rate of interest in this situation comes out to be 8%. Let's move on. A certain sum amounts to 15,500 rupees in 2 years at 12% per annum simple interest. That means the amount has a principal plus a 24% interest on the principal. or I can say it has 100% principal plus 24% of the principal, because I'm using simple interest over here. That means 124 percentage of the principal is equal to 15,500 rupees. When I tend to calculate it, P is 155,000 upon 124 multiplied by another 100. This value comes out to be 125,000. So the principal that I am sitting at is 12,500. The same sum will amount to what in 1.5 years in 10% per annum if the rate of interest is compounded half yearly. That means there would be three cycles. There would be three cycles. How would there be three cycles? We're talking about a period of 15, we're talking about a period of 18 months. 18 months is the time period we are talking about, and 6 months is the size of one cycle. So we will get three cycles, and for every 10%, the rate of interest would change to 5%, as it is a half yearly cycle. So I get a 5%, another 5%, and another 5%. What do I need to tell? I need to tell the compound interest. Okay, the same sum will amount to what? So what I'll do here is I'll quickly apply my formulas. This is 5 plus 5, 10. 10.25 in the first go, plus 5, plus another 5,125, and there is going to be a point over here. So 15.25 plus 5,125. Two zeros here, 21 here, 6 here, 7 here. So 15.7625. What do I need to do about it? I need to have, this is my basically my compound interest percentage that I have gotten here. What do I need to do? I need to do that principal has to be added to the compound interest. The principal that I have over here is 12,500 plus the compound interest in terms of percentage is 157625 multiplied by 12,500 divided by 100. This would be a little big chunky calculation, so I would want you to do it on your own. Okay, but I hope you're able to understand what we are talking about. Got it? This is going to be my final answer. Okay, let's move on. What is the difference between the simple interest and the compound interest on a sum for 8,000 rupees for 2 by 5 years at the rate of 10% per annum when the interest is compounded yearly? Okay, the interest is being compounded yearly. It means 1 year, 1 year, and 2 by 5 of a year. This means 10%, 10%, and 4%. If I talk about a simple interest, this comes out to be 24%. If I talk about compound interest, this comes out to be 21 plus 4 plus 21 into 4 whole upon 100. This is 84. This is 25.84 as my output. This is compound interest. This is simple interest value, which I already have. The difference needs to be given. The difference between 24% and 25.84% is going to be 1.84. This 1.84 percentage has to be multiplied by 8. So my final answer would come out to be 8 4s are 32, 8 8s are 64, 67, 8 1s are 8, 8 plus 6 is 14. So 147.2 rupees is going to be the difference between the simple interest and the compound interest. Okay, again, good enough. I hope you're able to understand. Let me move on. Okay, now we'll be talking about installments in compound interest. Okay, installments in compound interest. See, the installment money in compound interest goes in this way, that this is first of all installments across all, be it CI or be it SI. The installments are of equal amount. When I say equal, it means every month you have to pay the same installment. So for the first year, you have to pay A upon 1 plus R upon 100. For the second year, you will have to pay again a plus 1 plus r upon 100 raised to the power 2. For the third year, a plus 1 plus r upon 100 raised to the power 3. Okay, what would this entire situation amount to? This entire situation would amount to the pending loan. Okay, the pending loan. This is how installments is going to be taught, where a is the monthly installment or the yearly installment. Got it? Let's go ahead. A man borrows a sum of 1025 and pays back in two equal yearly installments. Okay, so 1025 needs to be paid back as a loan, and a is the monthly installment, and 1 plus 5 over 100 plus a upon 1 plus 5 over 100 square. Okay, so this is a whole upon 21 by 20 plus a whole upon 21 square and 20 square. Okay, so this 21 square is in the LCM, so this would become 420 times a plus this 21, this 20 square would turn itself into 400 times a whole upon 441. Yeah, I can say that. And 1025 is the value of each, is the sum which is supposed to be borrowed. Okay, so I have 441 over here in the denominator, and I have 840 or 820 in the numerator. When I tend to solve it, I get this situation that 1025 is multiplied by 441, and this entire scene is divided by 820. Okay, this entire situation is divided by 820. For this particular question, I will be using a calculator, but I would recommend that in the exam you try to solve this question somewhere in the end. Okay, please try to solve this somewhere in the end. So 1025 divided by, sorry, 1025 multiplied by 441 gives me 1025 multiplied by 441 gives me 452025. 452025. When it is divided by 820, I get my final answer as 551.25. Okay, do this calculation towards the end of your exam. Okay, because this question might take up the time which in which you could solve 3 questions. Okay, good enough. Let's go ahead. A mobile phone is available for 79,860 by cash payment or by paying a cash of 60K as down payment and the remaining amount in 3 equal annual installments. If the shopkeeper charges an interest rate of 10% per annum compounded annually, then the amount of each installment is what? We are talking about 3 installments in this case. So my answer would come out in this situation as the pending amount. The pending amount is 19,860. The pending amount is 19,860. 1 plus 10 upon 100. Again 1 plus 10 over 100. Again 1 plus 10 over 100. This situation is going to get squared and this situation is going to get cubed. Again an a over here, another a over here. There are plus signs in the middle. Okay, so if I have plus signs in the middle and this situation comes out for 11 by 10. Okay, so this is 10a by 11 plus 100a upon 121 plus 1000a upon 1331. When 121 is multiplied here, I'm simply taking the LCM. When 1210a plus 1100a plus 1000a. Okay, the LCM comes out to be 1331 and 19860 comes here. When I add all of them up, I get a 0, I get a 1, I get a 3, and I get a 4. Let me check it. Okay. This is 3 or 0. I get 1, then I get a 3, then I get a 3. Okay. This is not 4310. This is 3310. Okay. This is 3310 times A divided by 1331 being equal to 19860. Okay. 19860. 1331 can be cancelled only by 11. So I'll have to figure out a way in which 331 can cancel out this. I believe it's a simple multiplication of 331 ones and 331 sixes. So the value of A is 6 times 1331, which is equal to 6 ones are 6, 6 threes are 18, 6 threes are 18, 19, 6 ones are 6, 7. So 7986 is my final answer. The questions on installments are always calculation intensive, but try to do these questions towards the end of the exam. Do not take up the question in during the beginning. Okay, do not take up the question during the beginning. It's a very good advice that I'm giving you. It must be applied in the examination. Now we'll talk about installments in simple interest. The installments in simple interests are followed on one principle. We are assuming that 100 is the amount which has to be repaid. So the first thing we have to add is 100. The second thing we have to add is 100 plus r. The third thing we have to add is 100 plus 2r, and so on. Okay, so I'll quickly solve this question for you. I've already put up the solution. Why? Because I believe it is better for you to understand it through the solution. The amount which is borrowed is 2000. 5% is the annual simple interest, and 3 equal installments need to be paid. Okay, 3 equal annual installments need to be paid. If 3 annual installments need to be paid, that means an effective rate of interest of 15% was applied. If a 15% rate of interest was applied on 2000 rupees, that means I earned an interest of 300 rupees in total. That means in the end of the year, at the end of the year, instead of paying 2000 back, I was paying 2300 rupees back. So this is the pending loan which I have to pay by using my 3 years time. Okay, so for the first installment, if I'm letting the first installment to be 100, the second installment is going to be 105, because I have taught you this concept for installments in simple interest, and the third installment is going to be 110. This means the total amount is going to be 315 units. Okay, when I have a total amount of 315 units, my installments my installments are 100 rupees each, or 100 units each. That means the value of 315 corresponds to 2300, and I need to find out the value of 100. So basically, using the unitary method, I would write 2300 upon 315 multiplied by 100, which would give me my answer as 730 60 by 63. 730 60 by 63 in mixed fraction. Okay, I hope you understood it. It's very typical. I would request you to do the same question multiple times. Okay. Anandi bought a smartwatch from an electronic store for rupees 4400. Since she had less money, she paid 2000 for down payment, and the shopkeeper offered her an alternative to pay 2440 after 1 month. Okay. So if 1 month is in question, that means 1 by 12 would be the time period. Okay. If the interest is being charged at simple interest by the shopkeeper, find the rate of interest. The rate of interest needs to be found out. It is a simple rate of interest. The amount which was supposed to be paid, was 2400 rupees. What was the money that she was supposed to return? The amount was 4400. It was the charge that was supposed to be paid. She paid 2000 rupees as down payment. That leaves her with a 2400 rupee loan. For that 2400 rupee loan, she had to pay 2440 including the interest. That means a component of 40 rupees was the simple interest. A component of 40 rupees was the simple interest, and that component of 40 rupees was applicable on the loan of 2400 rupees. So this means R by 12 multiplied by 2400 whole upon 100 is equal to 40. This is 12 ones are. This is 12 200s are. Two zeros are gone. 2 against this makes it a 20% rate of interest. That means my rate of interest against the simple interest option against installments, which has to be completed in 1 month, is equal to 20%. Okay, good enough. Understood. Let's move on. Find the share. So, here is a situation where there are two people, Ram and Sham. Ram receives some amount which is in 3 years, and Sham receives some amount which is in 6 years. The interests are compounded annually at 4% for both of them. If the amount which they receive are equal, that means the investment of Ram multiplied by 104 upon 100 raised to the power 3 is going to be the investment of Sham multiplied by 104 whole upon 100 raised to the power 6. This means Ram upon Sham would be equal to, when I divide them, the powers are going to remain in such a manner that 104 upon 100 raised to the power 3 would be my answer. If I calculate it off, I get 26 as the numerator and 25 as the denominator. So this is 26 cube divided by 25 cube. I already have the ratios with me. That Ram's investment in the entire situation is the cube of 26, which has been written over here. Sham's investment is 25 cube, which has been written over here. If they are asking what is the Ram's share, what is the share of Ram, then you can say this is the share of Ram. This is the share of Ram 17567, which is equal to 26 cube divided by 26 cube plus 25 cube multiplied by the total money which was supposed to be divided. So this would give you an answer in points, which I would recommend you do towards the end. The point where I have left you is the point from where only calculation is important. The concept has been taught to you before in this slide itself. Okay, moving on to the last question. 66300 have been divided between A and B in such a way that A receives, the amount that A receives after 8 years is equal to the amount that B receives after 10 years. Interest is being compounded annually, and 10% rate of interest is the situation. A has 8 years in his kitty and B has 10 years in his kitty, and there is a 10% compounding interest on both the areas. So 1 plus 10 upon 100 whole raised to the power 8 multiplied by A's investment is equal to B's investment multiplied by 1 plus 10 over 100 raised to the power 10. If I do A by B, I get the value of 11 by 10 whole square. How did it become a square? The things inside the bracket are equal. The powers are on opposite side. The powers would get subtracted. Why? Because the powers are going to become in the numerator and denominator. When the same base is available and the numerator and denominator is available, at that time the powers get subtracted. So 11 upon 10 is my situation. So 121 upon 100 is the ratio of the shares of A and B. Now, what do we need to tell? Okay, I need to tell the share of A and B. A's share is 121 upon 221. Yeah, this is A's share. What about B's share? B's share is 100 upon 221. Let me multiply the initial amount with it. 66 300, 66 300. This is 1za, this is 3za, this is 1za, this is 3za. So this becomes 36300. This becomes, this should have become 1,000. No, no, this becomes 30,000 because there are two zeros here and two zeros here. So I get 30,000 here and 36,300 here. So C is my final answer. This brings us to the end of simple interest and compound interest. We'll be coming up with advanced maths now. Okay. Thank you.